The fact that these are breaking in different ways suggests to me that there's possibly a common link of two.
You shouldn't be able to get any of that for your vehicle.
Hello people of the internet. In the last video on the Citroën dispatch, I dealt with how Citroën handled customers when their vehicles break within warranty and how I, well, fixed it myself. Well, sort of. Anyway, in the last video, you guys asked how exactly did I fix it and save myself £2,500, bearing in mind this is a problem that affects the whole Stellantis range, the cars, not just the vans, and also what exactly went wrong with this unit. Let's get into it. The first step, like any modern vehicle, is to read the fault codes. And of course, you can't use a basic OBD reader. This won't communicate with the onboard charger to read these codes. A little bit like how your Bluetooth or Wi-Fi OBD reader with your phone app will read the engine ECU, but not the headlamp ECU, for example. So you're going to need some sort of scan tool that's a bit more competent than the OBD tool. I used the Think Car scan tool to talk to the onboard charger, and this is what it came up with: a charging error. The frustrating thing was that compared to the official technical service bulletin, the Think Car tool didn't show the full code. It cut off the dash and the last two digits. So while I couldn't see the full dealership level information, it still gave me enough information to know that I needed to replace the onboard charger. Even after clearing the fault codes, the problem continued. There is a technical service bulletin on the diagnosis and repair procedures for this part. Depending on the fault code that comes up, there are different tests that can be done with a multimeter to check for continuity and right levels of resistance to narrow down the problem. But for 90% of people that are having charging issues, given that these chargers are known to be a weakness, you can pretty confidently avoid those checks and just swap out the part. So of course, this is what I did. I have already disconnected the battery about 10 minutes ago. We'll let things power down, we can get this entire thing off. There are a lot of capacitors inside this charger and they need to discharge so that you're not hit with high voltage. So while you're waiting for power to drain down from your 12 volt system, you can remove the 4 10mm bolts that hold the plastic cover on top. Sometimes they're hidden under little plastic covers. Then you're ready to move on to disconnecting all the wiring plugs. All of them slightly different in how they disconnect and remove. It feels a little bit like one of the Bop It toys. Does anyone remember those? Try to move these connectors out the way by bending them down, which will leave you with 2 coolant pipes to remove. You're going to want to clamp these, and it is very important. This whole coolant loop travels around the battery, the motor and the inverter. If we leave these open, we're going to get air into the system, which would then require vacuum bleeding to avoid air pockets. Some DIYers might have this, others not. Something as simple as having air pockets in the motor or in the battery is enough to brick a vehicle. This is all avoided with 2 clamps. I used woodworking clamps. They were less than ideal because they're pretty bulky, but they did the job. There isn't much holding the entire unit down. There's 2 bolts at the front and 2 at the back. I feel like they were 13mm.
I'd say that it's gone okay if I've only dropped one 10mm.
One 10mm found. The 2 at the front are nice and easy. The 2 at the back are tucked between the onboard charger and the bracket that mounts it to the motor. I'm sure that this is probably easier in the cars, but in the van, the whole unit is tucked low and it requires you to crawl around, getting it in behind the bulkhead area. One of the challenges is that the back of the unit has a number of cables clipped in place. It can be a bit of a challenge to pry these off. If you've ever taken a door card off, you know what I mean. But just go easy and they'll all come off without breaking anything. On the back of the unit is also the negative stud, which grounds the casing of the onboard charger.
So we've got a couple of earth straps. There's one, there's the other. There's a whole bunch of wires which all clip into the back, and then there's a bolt that goes in down here. And those are the trickiest parts. Everything else was okay. At one point I dropped the ratchet down there and that was looking sketchy. But there we have it. It sits on top of there. Wouldn't ever want to change that valve, but I've had worse jobs.
You're then ready to spend 10 minutes wiggling the unit up, and it's not ready to come out yet. There's a connector that attaches to the underside of the unit, and for me at least it required a lot of wiggling to be able to disconnect it. There doesn't seem to be much spare cable. Basically, I'm just warning you, don't think that you can just yank the unit up and pull it out. Now I hope at this point that you picked up a replacement and you picked up the Chinese VMAX brand rather than sticking to another potentially dodgy mount product like I did.
So there is the old and new. I've swapped over this cable and they are exactly the same part and look about the same condition. Same pinouts, same colours on everything. So let's put that in.
I purchased this unit only a few days after dealing with Citroën, and I could already tell at that point that they were going to be difficult. And repairing things myself, I couldn't help but get the ball rolling and come up with an actual solution. This meant that I hadn't yet worked out that I needed the Chinese model to avoid any possible future problems. So I'm just warning you, don't make my mistake. With all of that sorted, the unit pops down and you're left just trying to connect the unit up to the underside. It's then time to practice your not hand-eye coordination as you fumble around in the area where the two rear bolts hold the unit down. Do the same for the front two, thanking yourself that you left the easy ones to last. Maybe you should actually do the front ones first to make it easier to line the back ones up.
I'd say that it's gone okay if I've only dropped one 10mm. One 10mm found.
Okay, and then you're ready to pop your coolant hoses back on. As long as you have plenty of fluid in the reservoir at this point, you can remove the clamps and then continue to install all the other electrical connectors. I collected the coolant out of the old heatsink and then poured it back into my coolant reservoir. There really wasn't much, but it made sense to stick it back in there. With everything connected, double checking that all of the locking tabs are in place, and then having one more final check to make sure all the connections are as they should be, you're ready to reconnect your 12-volt battery.
I'm gonna need my box.
So it's so high up in here, I've been standing on a box to do the entire thing. So this should just connect up absolutely fine, maybe a little spark. This is then a good time to check your coolant reservoir. You can see there's bubbles from where the small amounts of air is making its way through the system with the ignition on and the pump running. As I said earlier, if you were to replace the battery or were to allow a lot of air into the system, you would need to vacuum bleed it. So that simple preparation beforehand avoided a whole nother job. Well done you. I mean, most people aren't going to do this job, but thank you for watching. I was curious as to what the vehicle would now do with the replacement part.
Made a few clicks. See if it does anything. Bit of a waste of time, I think, because it does need code into the vehicle, but I'm just intrigued as to what it's going to do. Thinking it's connected to a Corsa or a Mocha. Doesn't look like it does anything. It does nothing. There you go. That proves it, that unless you have this coded, it doesn't even try to latch this thing in. It's obviously knowing that it's connected, it's connecting the two pins up, but the charger will not do anything. It's not getting the correct communication. Well, there we are, off to the dealer.
As you can see, it basically ignores that you've plugged into power. I suspect that the 12-volt battery wouldn't be charging either, so be careful at this point. And this is where Stellantis gets you. Oh. Okay, before we get into how Stellantis gets you with this unit, first, let's consider what actually broke. Now, you guys asked, how did it break and how easy is it to repair? So before we get into how Stellantis gets you, let's get into this unit. Okay, so on top we have distribution between our DC, our heater, and our aircon. This is all on a board with some fusing, which we can remove that distribution board. And then our top cover comes off nicely. You'll see that there's some thermal transfer to the outer plate, and there's a theme of that all the way through. They're using the casing itself as some form of cooling method. Okay, next up on the list, we've got to remove the ports for the AC input, and then pull up here, and this will pull out our AC input board that handles filtering, among other things. And this is where we start to find our first damage on this component here, where it joins to the coils below. We see some heat damage here. There's some discoloration on phase 1, which is the AC 7 kilowatt, whereas the other two will be the 3 kilowatt for 3-phase. Okay, so there's some signs of heat there. Smelling it, we don't smell an obvious sort of burnt component smell, but there's definitely a smell in here. I'm just not sure how to describe it. Okay, then ordinarily this board would come out first. I've still got them linked to this giant capacitor bank and this plate. Now this plate has a nice hidden screw underneath there, but that needs to come out the way. This is a board which does some filtering for our distribution above, and then we have this giant capacitor bank. Now interestingly, this capacitor bank is split with a middle, which says to me that they're running the bus voltage higher than the rated amount of 450 volts that these capacitors run at, or they're running close to it and they're just wanting to make sure that they last and that they have longevity. So the bus, basically the voltage that's in between the outside AC and the DC, is most likely higher, and that just allows for efficiency. And this is the most dangerous part, I would say, in the entire thing, because that has the ability to hold enough energy through those pins to kill a man. I'm not joking. Okay, and we're barely into things so far. Next on our list is this board here, which is our communication board. This is where communication with the vehicle comes in. I don't know why there are so many cables coming in here and what they all do. I cannot find wiring diagrams. That main board isn't too difficult to get into. We've only got to take a few boards out, and it handles the communication, the CAN bus, and it clearly has the main processor. And I suspect that we could take that out of our donor replacement second-hand part, pop that one in, and save ourselves a trip to the dealership, and not just that, save ourselves with sending money to the dealership when we could just put it into our own vehicles, hey? But considering these all have a possibility of failure, you're better to move to the Chinese one, and I don't know whether this would go in the Chinese version. If you fancy having a go at that, or you've done that, then please let us know in the comments. Thanks, guys. So with that out the way, we can see these are our incoming coils. And if you look closely at them, look, if you're enjoying this content, I need you to like and subscribe so you can be sure to see more Battery Man content. You can see discoloration on these and cracking in the center. In fact, this side here is completely cracked away from the aluminium, which suggests to me that we have some heat in here. Even this side as well, there's cracking, and since they're using the aluminium case to provide cooling, then it's possible that those were not able to transfer as much heat away as they possibly could, and we do see that with the browning that's on there. Everything else we attack from the other side and is using these pushy connectors, which will push out the way. So let's flip it over. So we have our incoming and outgoing cooling, and relatively, this is actually quite small, and you've seen all those electric boards so far, and it's only in contact with the very bottom most components, which are these. Now these are the switching components, and they will get hot in running, which is why they have a cooling plate. They have some sort of conformal coating. It was nice and clear, but I've ended up using the Dremel, which has resulted in this being unclear. But I've pulled away all of this material and tried to test each of these components, and I can't find any obvious damage. There doesn't seem to be any shorting between these, and if that had happened, you would expect to see that visibly very obvious because it would blow. But having said that, there are people that have reported these type of failures. So that is the only board in the entire thing, these two boards, which are in contact with the cooling plate. Okay. So on top of these, there are really, really wide copper traces, and I've tried to use the biggest soldering iron I've got to melt the solder so I can pull these boards off, but it wasn't working, so I've had to Dremel our boards below to get them off. On the one side, you have a board that has a whole load of components. There's quite a weight to this board. You could tell that there's some thick copper traces in here. Okay. And that has its own processor here of some sort. Moving on then. This then has a load more coils, and then on this side we see some more heat damage, if I can get this out. These are pushed into these pegs. There's like 8 of them on this board. So we've got more communications that lead back to our main control board, and there are more control pieces on top of this board. Now this is actually a sandwich of 3 boards, okay, with some, like, that is heavy. There are some thick copper traces on the back of here, but if I can take this bottom one off for you, going across to our coils on the top side, there was some of these spring type retaining pieces, and you can see that this one here is, there's a visible signs of heat damage there. So if I switch it over, I'll show you what that translates to on this side. So it translates to the pin down here. Okay. So it translates to the pin down there, out of this coil. So on our output side, we have got hot. So we've got hot on our output side and our input side. Our capacitors came in here. Everything else on this board that looks damaged is just me trying to Dremel it and pry it up. I managed to pull some of these off here. But you can see the damage on that component. You can see the heat makes its way through to the far side. It's visibly darker than the other side. Okay, so what on earth are we seeing overall? We are seeing a lot packed into a small space with multiple boards. Honestly, if I just bring over some of the piles of boards that are inside this thing. Okay. And we are reporting multiple different failure modes across these chargers. Okay, so how likely do you think it's going to be for a company to repair this? Now, I couldn't find a specific component that had failed that maybe led to certain things here, but they do run hot. I have measured this with the thermal gun. I've seen about 50 degrees. There's clearly components that are running hot here. The outer case is hot, so what on earth are the temperatures like inside here? We've seen in 2 different places signs of thermal damage, and we've seen cracking in areas where you just don't want cracking and discoloration on those coils. So I would say that the design probably runs too hot. It's just been designed in a way that doesn't thermally manage what's inside here. That's my guess. It doesn't mean that that is what is actually causing these to fail, but it shows that there is a contributing factor to this. It would be interesting to open others that have failed and see how they have failed, if they failed in a similar way. And really the question for me is, for the price of about £250 for a second-hand one, that includes the VMAX, the Chinese one as well, then why would you bother going to the effort of trying to repair a board that has so many boards like this? If it was just a really simple capacitor or something on the top, if one of these was clearly blown and then shorting that bit, whatever, you know, if it was that easy, then great, but it doesn't appear to be. It's just a jumble of multiple components. A lot of design work has obviously gone into this. Anyway, even with a replacement charger installed, you can't just plug it in and go, because Stellantis decided you needed their special software to make it work again. And this is where Stellantis gets you. There is no need for this part to be coded to a vehicle. I've replaced onboard chargers on other vehicles and you just swap it in and it works. It's up to the battery BMS to decide how much power it wants to accept. The job of the charger should be simple. Provide the correct voltages and the requested current follows that voltage request. But no! Stellantis decides that you need to code this to your vehicle. It's entirely possible that the design requires certain data to be set, such as expected 12-volt battery size or the type of battery, AGM or flooded lead acid, so that the charger can work out how much power it's outputting. But come on, does it really need to be online coded? Stuff like this really annoys me because it blocks the DIYer from being able to work on its own vehicle. I don't think for a second that saying, oh, it's electric, you're dealing with high voltage, is enough of a reason to say that people shouldn't work on their own vehicles. If people are willing to consider the basic safety requirements of working on dead systems and are competent enough to change brakes on their own vehicle, which of course, if not done right, you could plow into whatever is in front of you when you press the pedal, then come on. Please don't make this stuff appear to be like voodoo that the mortal man cannot possibly do. Where was I? So you're gonna have to find somebody with Diagbox. This is the Stellantis software for diagnosing and coding vehicles. Now, there are dark places on the internet where you can get copies of this. And using a scan tool that you can buy from AliExpress, you can read codes on your own vehicle. Haha. But like most things, they've moved away from the local-based to online-based versions of the software for newer vehicles. This means that all those copies won't read the onboard charger of this vehicle. Damn it! Added to that, the software needs online access to code this vehicle's replacement onboard charger. This requires you to be a limited company working in the trade to gain access. Because it's such a specific software with costs, you're unlikely to find an independent garage who bothers with doing this. Now, there are other ways around this. Having people use their online access through remote connection into your computer to do the coding. Maybe you can trust these people, but it also feels a bit of an open door, and I wasn't prepared for that. So I took the vehicle down to the real con artist, the Stellantis dealership. The dealership that I took the vehicle to over the warranty claim refused to code the onboard charger, claiming safety. Feels like walking into the ring. I've got the technical service bulletin here.
Yeah, how have you managed to get that? Yeah.
Like,
how have you managed to get that?
Huh?
How have you managed to get that?
Well, it goes through like the repair procedures.
Yeah.
And the diagnosis.
How have you managed to get that document?
There's also like articles on the internet showing how they fail.
My question: how have you managed to get that document?
Huh?
How have you managed to get that?
What do you mean?
This document here. How have you managed to get it? You shouldn't be able to get any of that for your vehicle.
Do you not think the right to repair is a thing?
No, I'm not saying that to you at all, am I?
Yeah.
All I'm saying is that is basically dealership thing.
I understand what you're saying. It's the dealer tool, and it's a technical service bulletin which shows that it's a known. It's a known issue.
First thing Citroën will ask me is how did the gentleman get his hands on that, because they're going to think I've given it, yeah.
Yeah.
And I haven't, and you're saying.
I 100% wouldn't say you've given it me.
Well, then I promise
I'll
just give you your keys back and say there you go.
No, I promise you, I wouldn't dream of doing that.
So again, as I said, if you can't tell me where you got that from, then we're at a standstill, aren't we? I can't go off anything you found off the internet, unfortunately.
Into Vauxhall down the road, the fact that it's been on a different vehicle, the fact that it's been coded to that vehicle, they can write a new. They're happy to code vehicles if they're supplied with a vehicle that needs coding. However, a local Vauxhall dealership were happy to help, and to be fair, they were way more familiar with these onboard chargers. At least one saving grace is that the second-hand units are not coded to the vehicle and then locked, so you can make use of the second-hand parts market. Overall, the cost of the unit was £130, which, having discussed the options earlier, I don't think that was too bad, even if it is a frustrating cost that just should not exist. What do you think? Should manufacturers like this be allowed to block simple repair procedures behind dealer-only software? Let me know in the comments. So as soon as they coded the charger, it worked as if it did before. I find randomly when my battery is getting full that the vehicle decides to halt charging and reduce the charge rate, then ramp it back up. I presume that that's just some software design for this charger or some weird BMS logic. Let me know if you've seen this with your Stellantis electric vehicle. So there's the full story. Diagnosing, replacing and digging inside the Stellantis onboard charger, in particular the e-dispatch onboard charger. All in all, the replacement took about an hour, including filming. I spent more time trying to work out how I could read the codes with the offline versions of Diagbox. It's a pet hate of mine that all of this repair material and tools are not just freely available on modern vehicles. This is one of the reasons that I'm more keen on Tesla. You can genuinely access all of their repair manuals at no cost, and anyone can pay for the advanced diagnostic tool built into the car. And this is how all EVs and modern vehicles should be. You just shouldn't have to take them to court to make right to repair available, hey?
People of the internet, if you are going to buy a car, you do not want to buy a lemon like these things. And this is where this week's advert comes in. Oh, drop me lemons. And it's V-check. Before you purchase a vehicle, you need to do a vehicle check. And this is where V-check have got you covered. You see, V-check are incredibly affordable with price, and I've been using them for a little while. Take, for example, when I brought this Nissan Leaf, right? This shows for the first year of its life, and the previous owner didn't know this, but it was a taxi. Now, ordinarily, I would avoid taxis, but it told me that it was only for the first year of its life. And for a 9-year-old vehicle that was £600, I was happy with that. But there could have been more lemonness behind the scenes that I would have missed had I not done that check. Now, you will not get a huge discount from them with me because their prices are already incredibly affordable. I think it's £6 or £7 per check, which is amazing. However, one way that you can help this channel is by using my code below, which gives a little bit of a payback for you using their service, and it helps this channel to continue to grow and put money into financing videos like this. So enjoy, guys. I don't know how people just eat lemons. Like, it's too much, right?
If you found this video useful, give it a like and let me know in the comments what you'd like me to dive into next. Thanks for watching, guys, and don't forget to subscribe for more of the shenanigans. I've quite enjoyed giving my honest views on Citroën and Stellantis in general, and I've quite enjoyed exposing something that people aren't talking about. So yeah, maybe we'll do more of this in the future. Hopefully not at my expense of things breaking here. Maybe other people can report common things that break to me.